In this video, I am going to start from the last topic. It is about software development life cycle. We have discussed about different phases involved in software development life cycle. Now, I am going to discuss about two or three models that can be used to develop any software or you can say system. Okay, so what is SDLC model? SDLC, or you can say software development lifecycle model or system development lifecycle model, a framework that describes the activities performed at each stage of a software development project. So the model is a framework that describes the activities performed at each stage of that software development of that project. So the first example of a model is waterfall model. Here you can see the steps or phases comes like a waterfall procedure. Like requirements will be first. At that phase of requirements defines the need, that information, function, behavior, performance, interfaces. At the design phase, data structure, software architecture, interface, representations, algorithmic details, those are put down in the design phase. In the implementation phase, source code, database, user documentation, and then go for test phase, and then installation phase, and then maintenance phase. But mainly requirements phase, second design phase, third is implementation phase. Here you can see, suppose this is a picture, you can understand how the work of waterfall model follows. Here you can see the question, how do we start our entire course if we don't know what's ahead? Means like at this stage, if you don't know what is ahead, you'll try to understand or you'll try to ask the question, how do you chart our entire course if you don't know what's ahead? But what you try to do, whatever happens, just keep pedaling. So you try to initially build that plan as a vague, in a vague way, but in the vague way you try to go for like whatever happens, just keep pedaling. So next, it is like this is in case of building. In case of planning, we cannot directly say that we can plan for the entire project because we don't know what will happen in the future. But in the building phase, you just try to keep the thing going, or keep the building the project as the things comes on, as the requirements comes on, you try to build on and on. And then in the third, in the testing phase, I wish we had designed for the scenario up front. So you might think upon like that at the testing phase, that in the before phase or in the build phase, you might have done something good better than broken down your boat. Here I wish we had designed for this scenario upfront. So whatever we can do, we may have done it in the previous phases for better result in this phase. And then the launch, when you launch your software, patch it as best we can. No time to change course now. So at the last, while do launching, or we can say installation, or we can say maintenance, however we can patch, we need to do that, because there is no time or no way to change the course of your project. So that is the idea about waterfall model. So actually the strength or the very useful keys of waterfall model is that it is easy to understand, easy to use, provide structures to inexperienced staff. Suppose you have inexperienced staff to develop a project, then you can go through it, because it provides that type of structures for inexperienced staff. Milestones are well understood, sets requirement stability, good for management control, and works well when quality is more important than cost or schedule. So here you can see, when you don't think about the cost or the schedule, you can work through waterfall model, because you might attain some quality rather than but to attain that quality you might lose lots of money, or you cannot maintain the schedule also. But if you don't think about those points, this waterfall model might be good while developing a project. But deficiencies are more, like all requirement must be known upfront. That is the problem. If you don't know some requirements, then you cannot build that thing in through that waterfall model. That is why if you go through the phases of your software development life cycle using waterfall model technique, then if you don't know some requirements, then you will build up the software, you will test the software without knowing those requirements, then you might fail. So that is why it is important that all requirements must be known upfront, otherwise you might fail, because there is no looping back of the looping back system or feedback system between any phases. So deliverables created for each phases are considered frozen. So here you can see deliverables created for each phases are frozen, inhibits flexibility, can give a false impression of progress, does not reflect problem solving nature of software development, iterations of phases. Integration is one big bang at the end. So integration only done at the end. Little opportunity for customer to preview the system until it may be too late. So in the whole process there is little opportunity for the user or customer to understand or to preview the whole system, and it might give a false impression of the progress. So when to use waterfall model? When you have very well known requirements, when you have product definition, a stable product definition, and when you know or understood the technology well, or you are trying to build a new version of an existing product, when you are trying to build a new version of an existing product, or porting an existing product to a new platform, in that type of scenario you can go for waterfall model, because in that type of scenario the risk will be less, and that is why you can use the waterfall model, because in that way you might achieve the or you might end the project in a good manner. But high risk for new system because of specification and design problem. So if you are going to build a totally new system, then it will create a high risk. Here you can see new version of an existing system or product can be built using waterfall model, but totally new system cannot be built, or it may be high risk one. Low risk for well understood developments using familiar technology. If you know the technology well enough, if you have the well understood of the development, if you know the requirements well enough, then it might be good to use waterfall model. Then there is another type, that is V-shaped SDLC model. Actually this is a variant of waterfall model that emphasizes the verification and validation of the product. Here what is done is that emphasize the verification and validation of the product. Testing of the product is planned in parallel with a corresponding phase of development. So here you can see along with every phases there is a testing phase associated with it, like project and requirement planning, then try to understand the production, operation and maintenance, then product requirements and specification analysis, they try to understand system and acceptance testing. Architecture, high level design, they try to understand the or do the integration and integration testing. And detailed design, they try to understand the unit testing, coding in the last. So for every phases there is a testing case associated with it, means they try to validate or verification for every phases. So testing of the product is planned in parallel with a corresponding phase of development. That is why this thing become like a V. That is why this shape is called as V-shaped SDLC model, which is a variant of waterfall model. What is the variant? Variant is that for every phase there is a verification and validation procedure involved. Means testing of the product is planned in parallel with the corresponding phase of development. So here you can see like that as per the as per the V-shape model, SDLC model. For as per we go down, in that way that thing will be connected, like project requirements planning will be connected with this one, product requirements and specification analysis will be connected with this one, means this is the verification and validation phase. Architecture or high level design defines how software functions fulfill the design, and to validate this or to verify this you need to use integration and testing. Check that modules interconnect correctly. Detailed design, develop algorithms for each architectural development. For this type of design you need to perform unit testing. Check that each module acts as expected. Or coding is lone one, you can see in this video also, coding is not connected with any verification or validation. So this arrow is downward and this arrow is upward, and in that way those testing and validation is connected. So strengths are like emphasize planning for verification validation for the product in early stages of product development. So at early stage itself, the emphasize planning for verification and validation is put forward. Its deliverable must be testable, means every product or any deliverable following a V-shaped SDLC model must be testable. Project management can track progress by milestones and easy to use. Weakness is that it does not easily handle concurrent events. So if some events are concurrent or parallel, suppose some events like architecture, high level design and detailed design are happening concurrently, then it will be a problem to test in that type of concurrent situation. So that is why does not handle concurrent events and does not handle iterations of phases, does not easily handle dynamic changes in requirements. Here you can see, if you change something dynamically, if you or if you do iterative work in some phases, or if you do concurrent work in some phases, then it will be problem to validate or verify or follow the V-shaped SDLC model, and does not contain risk analysis activities. So throughout the V-shaped SDLC model, we have not find any risk analysis activities. So when to use the V-shaped model? V-shaped model is excellent choice for system requiring high reliability, like hospital patient control application, or all requirements are known upfront. Here also, as like waterfall model, we need to understand all the requirements upfront, means before developing the system. When it can be modified to handle changing requirements beyond analysis phase. Sometimes something can be modified to handle changing requirements beyond analysis phase. So, and also solution and technology are known. When you know the solution and technology, then also you can use V-shaped model. Next one is spiral at SDLC model. We will try to discuss this spiral SDLC model and incremental SDLC model in next video, and try to go through the topics or points I have discussed in this video, in this current video, and also try to go to the books also, and also through any literature found in internet. If you have any doubt, please let me know. We'll try to resolve it over Google Meet. Thank you.